Welcome back, Smart Contract Maxis. In the part two of token staking smart contract. In this part, we are going to we are going to test our smart contract which we have written in the previous video. If you haven't watched, make sure to watch it because in the part one we have built a staking token which is ERC20. Here I named it Rootstock Infra token. You can name it whatever you want, and we then build our staking contract, which is main our contract, which is ownable, and we have added re-entrancy guard to make it more secure, and we have possible for emergency pause, and here we have declared state variables and mappings, constructor, modifier, and some of the basic and some advanced functionalities like stake and withdraw, get reward, following the best practices. So in this video we are going to test all the smart contract. Throughout we are going to write a lot of test and we will test it rigorously. I will show you some of the best practices using Foundry, how you can test your smart contract, and we are going to test and to check what we have expect, whatever we have right and working as we expect. So let's go ahead and as I showed you like what we have done in the previous video, let's go ahead and start testing. For testing, let's create a new file inside the test folder, and let's name it staking test dot t dot sol. That's it, and let's start writing test pragma solidity 0.8.20, and let's name our contract staking test is test, and we have to import test from Forge standard library. So let's import test from Forge std slash test dot sol. Oh, I messed this up. Let me clear this. Forge std slash test dot sol. That's it. And also we have to import staking token and staking contract. Both of the contract we built in the previous video. Let's name what was the name, staking contract or the staking token, token from the dash slash not comma slash src slash staking token, and that's it. We forgot to add this here, and we are also importing our main contract, which is the staking token or the staking contract from dot slash src slash staking contract, and that's it. This is a VS Code error and it will go away. Now let's declare our state variables to set things up. So let's first deploy. Let's say staking token, copy this from here and paste, is equal to public, not we are going to declare first and then we will initialize this, right? So let's staking token and let's make it public, and let's name it staking token but in small letter. Staking token, let's make it capital, and let's copy it from here. We are going to declare this as well, staking contract public, and staking contract, and let's address public let's say alias, and let's say address 1, and address 2 of the Bob, uh, address public, let's say Bob is equal to address, let's say 2, and we also need the address of the owner, right? Address public owner, which is the this address, let's say this, and that's it. Our state variables we declare, and now let's set up our function. So we will go ahead and start testing. So let's say function setup. This is the mandatory function you have to write while testing smart contract in Foundry, and also make sure you are always making it public. You have to make it public whenever you are testing your smart contract in Foundry. You have to make every function public. And now let's initialize first our staking token here. To deploy is equal to new, copy it from here or the here. This is the same contract we are initializing here, and call it, and now staking contract. Let's deploy this as well. Staking contract is equal to new, staking contract. Now if you see here, it is taking some argument to pass, so we have to pass the address of the this staking token here. If you go back here inside our staking contract, and if you see here, we have constructor, and inside that constructor we are taking the address of staking token. It can be it could be any, but it could be any address which you are going to stake or to deploy this contract. But we already created, since we are already created, we are going to take the address of this staking token contract. So let's take it, address of the staking contract, sorry, staking token, uh, staking token, and that, let's format the document so that our code will be look beautiful. uh, and now we have to transfer some tokens to test users. Now let's say staking token dot transfer, and inside that transfer we are going to pass uh, inside that transfer we are going to pass, let's say ls, and let's say 1000 multiply 10 to power 10, and that's it. We have transferred some tokens. Now what we have to do, let's transfer Bob as well. So let's copy it from here entire and paste here, and Bob, right? And now we have to fund staking contract with token for some rewards, right? And now let's say staking token dot mint, or the, if you remember, we have mint function, address of the staking contract, and we have to mint, let's say this much of amount money, 1 million, and let's divide it to power 18, and that's it. We successfully set up our function. Let's format this again. By the way, if you don't know how to format your entire uh, Foundry code, just run this command. I'm going to give you the tip here for fmt, and it will format entire your Foundry Solidity code, no matter in which file you have code. It could be in src directory, test directory, or script directory. We are going to write script as well to deploy our smart contract. So let's first we successfully set up our function. Now let's test our first staking token, or test of our stake, and that is the let me go back here. And first let's test this stake, whether users are able to stake or not, or are there some problems. So let's go ahead and let's write our first test function, test stake. And here always, as I even my previous video, and now I am going to I am telling you again, always start your function name with the test when you are testing from your setup function. And always always your test function should be in public, their visibility should be in public. Now let's write function body, and here I am going to use the Foundry cheat code, which is vm dot start frank, vm dot start frank. And it takes one argument of the sender. Let's say here alias, there we have declared here. And in now we have to write staking token dot approve, and we have to pass the inside the approve the address of the spender and the value. So let's pass address of the staking contract. Now where is the staking contract? Copy it from here, and inside the staking contract, and the value is let's say 100 multiply 10 to power 18, and that's it. Now what we have to do, we have to stake some tokens, right? So let's take staking contract dot stake. If you remember, this in this function, stake taking one parameter as an amount, so we have to pass the amount here. So what is the amount? The same amount we are going to pass here, as an you can see here, we pass the same amount, 100 multiplied into power 18. And now we have to run this assert. We have to write this assert equal, which is the left side value. The left side value is taking contract dot, let's copy it from us, taking contract dot balances. If you see, the VS code also suggesting us, and AI also suggesting us, and the balances of the, let's say, LSS also franking. And the right side we have to pass this amount. And now we have to stop franking, vm dot stop frank, and that's it. Let's format this document, and let's see our first test how it is going by running for test. And if you see, compiler is successful, ran one test, the taking test, and our first test is successfully passed, which means our user can stake some tokens in our smart contract. Now let's keep testing the first. Let's test whether user can below minimum stake below minimum or not, or the whatever the smart contract logic we have, whatever the logic we have in our smart contract. So let's test this second function. And by writing function, let's say test stake below minimum test below below stake below minimum, and let's make it public. As I said, always your test function should be in public. And let's vm dot start frank, and let's say inside the start frank, now let's say alias, and now staking token dot approve, the same the same logic we have to write, but in different way. Suppose we have 100 here, so let's say 15 like this. So let's say, let's copy it from here, staking contract dot approve, and inside that approve we have to pass the address of the staking contract, sorry, copy it from here, and address of the staking contract, and the value is now this time, let's say copy it from here and let's make it 50. Let's make it 50, and now we have to write, we have to use the another new foundry cheat code, which is expect reward. So let's because we are expecting reward here, expect expect reward, which and inside that let's pass a string below minimum stake, because it will throw an error. And now staking contract dot stake, copy it from here, the same logic, and paste it here. Let's say 15, 50, not 15, and now stop vm dot stop rank, stop rank. That's it. Let's format our document, our code, and let's test again. And if you see, there we go, we failed something here. What are the problem? Below mistakes, not mistakes, are one passed, one failed. I think something wrong here we made. Let's say what wrong we did. Let's say him dot string flag ls staking contract dot approve, address of the staking contract, and 50 multiplied 10 and 10 to power 18, right? And here expecting reward below minimum take stake, and staking contract dot stake dot 15 plus to power 18, and the traces vm dot stop rank, and let's write dash vvv, let's say traces, we have something here. So I think owner of the asset 20 spender, and below minimum stake, and that's it. I think this is the test we are going to solve very soon. Let's stop, let's keep writing more tests, and let's now test withdraw. Let's keep writing function test with withdraw, and let's make it public. And now let's start franking, vm dot start frank, and staking token dot approve, from here the address of the staking contract, and the same logic we have to copy it from here. Let's copy it from here and paste here. There we go. What approve not or visible argument dependent, I think staking token dot approve, I think there is a problem. Staking token dot approve, address of the staking contract, let's keep writing, maybe this is uh, VS Code problem. Now staking contract we have to call, and staking contract dot stake, and the same amount pass from here. Let's copy it from here, and staking token dot approve. Yeah, we have the staking, and now the staking, because we declared these variables and we are using this is the same problem we have facing. So that's it, we solve this right here. Now if you go ahead and now we have to call the withdraw function, because we approved we stake, and now we have to call the withdraw function. Staking contract, copy it from here, paste dot withdraw, and let's try withdrawing some amount. Let's say this much of amount we have to withdraw. Copy it from here, and vm dot stop frank. We have to stop ranking user, and that's it. And let's test again, purge test, and our test one should be fail. I think, yeah, two passed, one failed, and or two paste which test stake and test withdraw fast, and the minimum below minimum stake is failed, which we will sort out in later, or maybe the the assignment for you. So I will solve this, and I will, at the end of this video, I'm going to give GitHub, fully GitHub repository for your reference, but you can try this and solve by it yourself. So let's test our another function, which is the rewards function. So let's keep writing some badass test function, test rewards, and let's make it public, and now pm dot start frank. So by the way, these are the some ls cheat codes. If you don't know where these cheat codes are coming from, you can go to uh, Foundry book.getfoundry.sh. They have latest documentation. You can go here inside the get started, and you can go in the test, and here are the overview how you can start testing in the comprehension. Here are the cheat codes you can study. So I am using the same cheat codes. So that's it. Let's go back to our code and keep writing some our test. So test rewards, and now let's call staking token dot approve. That's it only, and same thing we have to repeat. Staking token dot, let's copy this entire line and paste it here. uh, I think we mess up with something. Yeah, no, nothing mess up. So yeah, and now what we have to do, we have to stake something. uh, let's copy it from here, and for checking rewards we have to test. And now what we have to do, let's say some fast forward to, let's say, 1 year. uh, for that we have Foundry cheat code vm dot warp, and inside that we have to pass the block dot timestamp and the days. Let's say block dot timestamp, and plus 365 65 sorry, not 4000, 365 days. And now what we have to do, let's take a local variables here, unt 256, and how much to earn the catch the value. Now let's copy from staking contract and dot earn. There we have function, and earn the account of the ls, let's say ls account. And now what we have to do, we have to do, I think most of the you viewers of you never use this new Foundry cheat code, that's assert gt, assert assert gt. And inside that we have to pass the function of uh, earn function, and let's say 0 value. And now let's keep going, staking contract dot get reward, this is the function we have. And assert equal assert equal, and the left side we have to pass the staking contract, and we have to call the earn function, staking contract dot earn, and that earned inside the address of the ls. And let's say right side the 0. And let's keep writing our test before vm.stock rank. And let's format the document, I think we did something wrong here. Let's test, and there we go, again we have another failed test. Let's say forge coverage, and if you see here, encounter total 2 failing tests to succeed. And I deliberately did this because uh, if you see, uh, if you notice, we did something wrong here, and you have to identify. And now we can write multiple tests, but uh, I think that's enough because this video will be so long, even we have to write more deploy script. And I think that's enough test. So let's keep going and write our deploy script. And these are the some assignments I will in at the end of this video I am going to give you entire GitHub repository. There I will show, I will write more test of the, let's say, test exit and test pass also. Just like we tested as stake below minimum, and so I will also write test set minimum stake and set kind of duration and all this stuff. There are a lot of tests, but again this video will be so long. So these are the some assignments, try by yourself. And if you find it struggling or anything you can't do this, then I am going to give the GitHub repository, which you will find in the description of this video. So you can always go there and keep writing test. So let's clear it, and let's go back, and let's make it this contract for the, let's make ready this contract for the deployment on rootstock test network. So let's go inside our script file and create new file, deploy.s.sol, which is the script we are going to write. Let's keep writing pragma solidity license identifier mit pragma solidity 0.8.20, and contract deploy is let's say script, and we have to import script from the for standard library. Import script from for std for std slash script dot sol script script dot sol, and that's it. We also import these are the two tokens that we create. These are the two contracts that we created, because the both are the contract we are going to deploy on the rootstock test network. So let's first import staking token, which is the rootstock infra token. Staking token from dot 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 slash src slash staking token dot sol, and now import staking staking contract from dot dot slash src slash staking contract dot sol, and let's set up our function or the function run. Function run here, and inside the function run, let's start broadcasting. Vm dot start broadcast, and deploy the let's first deploy the staking token. What's wrong? Did you intended to public? Yeah, we forgot to add visibility of this function public. Vm dot start broadcast, and let's first deploy staking token is equal to new staking token, and let's now deploy staking contract is equal to new staking contract. Copy it from here, paste it here, and here we go. Now what we have to do, inside that we have to pass what is the wrong, has to be an value. Yeah, we forgot to add the name of our variables here, and here also staking, and that's it. Inside this we are taking inside, we have constructor in this contract, so we have to pass of the address of the token, which is the our contract. So this is where we have declared that was the one error, and that's it, it will be solved. And now what we have to do, we have to stop broadcast and print the value of our contract addresses that will be deployed. So let's stop this. Vm dot stop broadcast, and there we go. And now let's console, we have to import console from the for standard library, console.log staking token. Let's staking token deployed at and let's say address of the token address, and this is the variable we have here, pass it here, and that's it. Copy it from here, paste, and now staking contract or the main contract and the address of the staking. That's it. And now let's make it our let's format it, and our deployment script is also ready. Now uh, we have to deploy, but before going ahead and deploy our contract, we have to make some configuration, like the EVM version. Rootstock currently supports only EVM version of the London. So let's go here in foundry.toml, and let's set here EVM version of for rootstock. EVM version, let's say, is equal to London, which is the EVM London fork. And we have to set here our RPC endpoints. This is how you set RPC endpoints in Foundry. And here let's pass root stock testnet is equal to, I'm going to use this one which is publicly available. You will find it on rootstock documentation, but you can use yours. But again, here security, for the security concern, you can use, but you need to create .env file, and you have to hide this, because if you put it here, anyone can use, because our all the codes are open source. So this is the URL, https slash slash public dot node public dash node dot testnet dot rsk dot co. But if you go here and inside the documentation, and let's find it out here, rpc uh, rpc url. There are here you can search and find according to whatever you want. So here are the some two of the best, the testnet and the mainnet rpc url. So I am using this one. This is the chain id if you are configuring, and that's it. Also let's go back to our code. This is the rpc url. Also we need to add some faucets, although we have. Let's open my metamask with some codes, and there we go. I'm on the rootstock testnet. I have some faucet, it is enough, but let me show you how you can get your faucets in order to deploy. So let's go to faucets.rootstock.io, copy your wallet address and paste it here, and let's check this. I'm not robot, and when you turn, get testnet rbtc, and it will give you some rbtc. Let's check this. We have 0.3.67 trbtc, which is the testnet rbtc, and it will give you. Let's wait some couple of minutes, sorry, not couple of seconds. It will not take minutes, believe me. Before going ahead, sorry, it is going to give us till. Let me do some configuration. So I think we have done, that's it all. Let's make sure we have some all the 8.0 and let's 8.0, sorry, 20 8.20 8.20, all the smart contract the same. If you sometimes VS code or the while you are in development, it will give you some warning. So you can also set your Solidity compiler version as well here, just by, although I think we don't need here right now, but when you are doing development you have to do the Solc version as well. So you can put it like whatever the version you are using, 8.0.20 or whatever the version you are using. So that's all the configuration you have to do. Now let's go and deploy our smart contract. If you, let's go back, which you can see here, we have now 0.3.72, and it is giving us the sent message. You can check the transaction on the rootstock testnet blockchain, the success 1 minute ago already. And that's it. How many 0.0005 RBTC they sent us, and that's it. Now go back and run this command to deploy for script. And script, we have script folder. Inside the script folder we have deploy.s.sol, and inside that we have the contract name, deploy. And now we have to pass rpc url, which is the variable we have declared here, rootstock testnet, and we have assigned this rpc url here. And dash dash account, from which account we are sending. I have encrypted my key in my Foundry keygen wallet, so I have this wallet. You can do this as well using the cast. I have separate guide for this. Make sure to watch. I will also add this link as well. uh, so dash dash account, now dash dash sender. What are the sender? So this is the account I am going to use, and the same private key I encrypted. The sender is this. And now let's broadcast the transaction. We are broadcast, and let's say legacy, because if you do not add legacy here, it will give you an error. Let's hit the return or the enter if you are on user Windows, and let's see what happened, and we will debug it if we can't able to deploy our contract. Let's yeah, here is the rpc url. We forgot to add the dash here. Instead of dash, we added something different here. So let's go there, rpc url, and fix this rpc url. This is how you have to pass. Let's hit the enter, and let's wait for some time. So it is compiling all the contracts. We have 26 files with the compiler version of 8.0.8.30. Let's wait for some time, and let's see. So you can see our contract already deployed, but it will take some time because it is asking my account password. So I am putting my password here, which you have to which you set during while setting up your wallet. I'm just entering my password, and let's wait for some time. You can see all the logs here. Compiler run successful, script run successfully, and these are the tokens, staking token deployed at. You can see in your console you have written staking token deployed at the address and staking contract deployed at the address. Setting up one EVM, chain ID, estimated gas prices, estimated total gas used for the script, and estimated amount required. So it is taking some time. While you can go back to rootstock developer portal, they have also activator program. You can contribute whatever you can by writing, coding, adding value to their code base or their content. And if you go inside the developers section here, you can find all the documentation, the hardware requirement, and the prerequisites, and some you can see the prerequisites, what you need to know or as a developer before going to develop on rootstock. Here are some quick start guides. You can also write smart contract on uh, rootstock as ethereum using viper language as well. And they have previous starter kit, dynamic starter kit, web3 author starter kit, wagme starter kit, rewon starter kit, which is used for on ethereum. On account abstraction, we have the hardhat and hardhat ignition starter kits, foundry starter kit, account abstraction kit, DApp automation, RIF relay. They have like massive ecosystem and the development tools as ethereum. So You can also see some of the best guides here, just like for beginner friendly. For beginners, it is very beginner friendly. Deploy, interact, and verify smart contract using Remix and Rootstock Explorer. If you go back, they have getting started with alchemy guide as well, and there are a lot of comprehensive documentation uh, in if you find on their docs. So also use cases and some of the best libraries you can find here. So let's go back into code, and you can see here the success hash, um, contract address, the chain id, and all these logs you will find inside your terminal. Let's copy this address and check contract is deployed or not. So we are here on explorer.test.io. Just copy here the address, and let's wait, and you can see here the rootstock infra token. The symbol is RIF decimals 18, and who created this is the same address B9. You can see here I have B9 address, and 2 minutes ago total supply of this much, and balance it is holding 0 RBTC. Let's copy the second contract and check our, this is our main contract. Let's check if it is deployed on rootstock testnet or not. Let's see 7, and you can see here the creator of the B7, and this is the contract address 3 minutes ago, total supply 0 here, and the internal transactions, no transactions, events, balance history, accounts, tokens, balance history, and events. So ownership transferred, because in this contract we some did some logic here, right? And the contract here, you can also verify this contract by uh, uploading your source code here, and that's it. So that's it in this video. I hope you enjoyed, and make sure you are writing more tests here. I'm just I've been just giving you the starter kit, how you can test a contract. I written some fail test here, so you have to make it correct, or I am going to give you a GitHub repository of entire smart contract and entire testing throughout the rigorous testing of this smart contract. With that, I will see you in next video, or the next um, another exciting tutorial. Till then, bye bye, and